Okay, now I can. Okay, so thank you again for having me here. So let's talk about the using policy delay to gain the remote code execution and to execute the ransomware to infection with my machine. So this is my contact on Twitter, right? So at Filipi Pires, and here my contact on social medias, and I have here my webpage if you'd like to see some information about me and some talks that I've been participating in, some articles that have been published there. In my Twitter and my GitHub, by the way, and this talk is based on some articles. I'm not only articles, but I performed some tests, and of course I wrote some articles and I published it, and all those informations are inside of my GitHub here and my LinkedIn if you'd like to, send me a message if you have some questions. So please, you can send me during the conversation now or after this presentation. Okay, so just some information about me. Let me introduce myself. So I'm a principal security engineer at Talkdesk. It's a company from Portugal responsible to sell a product from contact center as a service. I'm a security research at Senha Segura. It's a global company from Japan. It's a privileged access management solutions. And my focus there is to make a research, actually, not only exactly in this way with this product specifically, but to perform some researches in different topics related to cybersecurity. I'm an advocate of the Hack is Not a Crime. It's an awesome project, by the way, that our idea in this project is to spread the message about the hacking, because hacking is how you can see the softwares and how you can use in your creative mind when you need to perform something related to a technology. And by the way, I will explain about this technique that I'm using this tests and how you can use in your hacking mindset, okay? And I'm a part of the coordinate team of the DEFCON groups here in São Paulo. And by the way, I'm talking from Brazil now in this moment. And I'm instructor of the Hacker Security or HackerSec. It's a Brazilian company. And I have a course of the malware analysis in Portuguese language. And I'm instructor of this fantastic magazine. I have a course of malware analysis and malware hunting, actually. And I'm a writer and reviewer in these 3 magazines. Okay, so just information about me. And before to talk about exactly the test, I would like just to putting all those people in the same page. So I would like to talk more about what is exactly threat, right? So just a simple definition. It's not my definition. It's according to this ISO. Just to explain more what is exactly, right? So it's a potential cause on an incident to may cause harms to the systems and organizations, okay? I mean, it's related, sometimes it's a software attack or a theft of intellectual property or maybe identity theft or sabotage or extortion of the information. All those things is related to a threat. So why I need to understand about the threat, Filipi? Because it's very important. You understand about the known threats and unknown threats, but you need to understand about how known threats works, because when you need to perform some investigations about that, or when you need to perform some tests in your environment, you need to understand the behavior about the threats, right? Because you don't know if it's malicious or not. If you have some sample, for example, or some artifact, you need to investigate more deeply. You need to execute some steps, and after that, you can understand if it's malicious or not, okay? So this is the first step when you need to perform something when we talk about the malware hunting or malware analysis, for example. The identification step is very important. You need to define if it is malicious or not, or malware, malicious software, or malicious document. And after that, you can define what the best methodology that you can apply inside that, right? So you define, you can use in the statistical analysis or dynamic analysis, right? You have a different approaches here. Maybe you are asking what is the best way. You can use both of them. It depends, of course, what the result you need to have in after this analysis, okay? And my recommendations to you is always when you need to perform some tests in this way, you need to prepare a report. You need to, register that, because when you register that, you can understand about all those steps that you perform in these tests, and you have the, evidence of your analysis and why you can do when you have this kind of information. You can improve your defenses mechanism, right? And by the way, this test that I performed, and I will present to you now during this conversation, I perform it in my environment, and after that, I can improve my defenses mechanism in that time when I perform these tests, okay? And of course, you can improve your cyber threat intelligence environment when you have. If you don't have, you can create something, you can build it right in your environment, because the threats are changing all the time. So you need to strengthen the cyber resilience, because again, when you are talking now during these presentations or during this conversation, probably someone are creating some new attacks, or even not only new attack, but creating a new variant of the same or the known attacks. Okay, so let me invite you to think in a different way. So because of this, I call change your mind. You know what is exactly cyber threat hunting, right? So, but my idea is to explain more about this different thoughts, because when you talk about the threat hunting specifically, we are talking about how you can see the logs in some tools, for example, or if you have a SOAR, right? Or if you have a CM, or if you have or if you're working in a security operations center, you see many logs. And of course, it's pretty important to understand the logs and to see the evidence. But how the attacker think, that's my idea here. Because of this, I call change your mind. Because when you talk about the hunting, you see about the cyber defenses with the offensive mind. So how you can see the process proactively and interactively searching through the network to detect and isolate advanced threats. Remember about that, threats. So how you can using your offensive mind to work with a defensive perspective. This is my idea here. So what is exactly Hunter, the people that works with Hunter? If you see in my social media, for example, I like to use a lot of malware hunting. It's not a normal, it's not common, this word is in them when you talk about the cybersecurity, but how you can using the hunting to, to searching something related to a cyber criminals or cyber attackers or something like that. And because of this, I would like to invite you to think a different way, right? So the threat hunter is a qualified security professional to recognize. So here is a good point, to recognize something this professional needs to understand about the known threats works. So how exactly is the behavior of the specifically binary that you are analyzing, right? And what kind of DLL this binary have, not only have, but what kind of function this DLL is imported by this function, or this function is imported by this DLL. So how this works in environment. For example, if you find some function called sleep inside of this binary, so probably this function is important from the some DLL inside of this binary, and probably this function is responsible to using or to executing some techniques inside of the environment that this malware is executed. This sleepy technique is more when the malware have been executed in some sandbox. It's another concept that you can using to analyze the behavior of the malware in controlled environment, right? So how you can recognize that. So because of this is important, you understand the behavior in a practical way, okay? The second characteristic is it's about isolate. So how you can isolate this threat to investigate and to see more deeply. And of course, the main topic is disable the potential APTs. It's acronym of the advanced persistent threat because it's more advanced. And of course, it have many other different techniques and characteristics of these APTs, the groups involved in this kind of attack, okay? So how you can use in the manual or artificial intelligence techniques to disable, not only disable, but isolate or recognize this kind of techniques, okay? And this professional is responsible to search some evidence in a possible internal and external intruder. So here we have in another interesting point. Internal, it means probably if you're suffering some attack, they have this kind of attacker maybe can be stay inside of the organization, inside the network, okay? So it's important to understand the behavior and to see what exactly is the place this attack are happening, okay, around your network, right? So let's talk about some techniques in using a threat hunt. It's very famous about the IOCs, indicator of compromise. Probably you know about that. So here's some characteristics or indicators like a suspicious and no hostile domain or IP, suspicious, no hostile file cryptography. But usually when we talk about the IOCs, it's only related to an attack and already happened. So it's a post-infections, right? And you can find by signatures to detect the suspect infections or non-hostile data such as antivirus or IDS signatures. You can see more information about some data or potential data related to some exploitations or some CVE IDs related to some exploiting using to explore some vulnerabilities. And you can see more deeply and you can investigate some indicators about the TTPs, the famous tactics and techniques and procedures associated with some suspect or non-hostile events, or maybe some behavior different, like for example, an unauthorized instance with a mini-cat, or for example, if you don't have any offensive team in your environment executing some scanning in your environment, so it's probably totally suspicious, right? So that's a good point. Another technique, but you have in the market here the malware information sharing platform. It's a platform responsible to consolidate many different evidences of the events of the attacks. It's an open source platform that you can see many evidences, like you can see here in this picture. This picture is from Google, so you don't have any information from the customer here, so no worries about that. But it's a good platform to see and to consolidate more information about IOCs. Remember, when you talk about IOCs, is evidence of the attack already happened. But how you can work with a proactive way. So here we can using another different techniques based on EOA, an indicator of attack. It's only based on the behavior and the why, what is exactly the intention of this attack. So this is very important to understand that. It's more a strategy view. It's more mature view, right? So it's more intelligence view when you're using. It's more mature intelligence program, right? So you can using to see the behavior, and when you understand about this behavior, understand about the known threats, you can work, so you can protect them your organization from the new attacks, or not only new, but the known threats, right? So this is very important. So some indicators included the real time behavior, not only limited on the endpoint behavior analysis, like, for example, if you see some non-standard behavior, for example, at 1 a.m., right, in your organization or in your company. Let's suppose that you have some past exec from Microsoft, it's as part of the SIS internals, executing some remote scripting in your environment at 1 a.m. It's not common if you don't have any GPO to executing and that time. So on this time, probably suspicious, because why? Remember the why. So why you are seeing in this log what are happened, this scripting running at 1 a.m. in my organization, if you don't have it. It's a totally real-time behavior, right? And another point is what kind of DLL. So now I'm talking about the DLL. What kind of functions are imported from the DLL? What exactly the sequence of the events, for example, like the same example of the PSSX, for example. When you see the logs, when you see the behavior, we can find, for example, not only 1 a.m., but 1 a.m., 2 a.m., 3 a.m., 4 a.m., some scripting running in your environment, but you don't have any, task in this time. So it's totally suspicious, but you need to think about that and you need to ask why it happened in my environment, okay? And user behavior in relationship to the digital threats, like some user trying to connect many times or trying to authenticate different apps in a different time, in the same time, but in different, for example, regions. So it's why it happened, because we just only one user, right? And how it happened. So maybe they have different access or they have some platform integrated with the systems, but why? We need to make a questions, okay? And another point is about the TTPs, techniques, tactics, techniques, and procedures, such using this kind of technique. And this is another point. So, Philip, I don't know what is exactly TTP. So how this works? So you need to understand about that. You need to, study more, and you need to gain the knowledge. You need, for example, read more about the MITRE, about the techniques in using in some attacks. So you need to find these informations. When you have these information, you can see the logs, you can see the binary, and you can create the hypothesis. And when you see that, you can, of course, asking yourself about why this happened in my environment, okay? And another point is something happening in my environment. It is persistent and stealth with stealth components. So it's totally using with attack. So why it happened in my environment if you don't have any, for example, applications running because sometimes we have some like a false positive in our environment because they have some persistent components, depends of course, depends of the applications, but sometimes we have. So we need to understand about that, and you need to think about the questions. Why? Okay. Here's some 10 suggestions to you about some indicators. So internal hosts with the bad destinations. Why it happened? Because, for example, let's suppose that you don't have any business with Brazil. Let's suppose that. So why you have some internal hosts to try to connect with Brazil if you don't have any kind of business with Brazil? Or internal hosts with a non-standard port, very common in many companies. So what you have some applications works in a different non-standard ports, right? So, or many times to have, or sometimes actually, we have a public services or DMZs to try to connect with the internal host. If you don't have any applications in this way, okay? And another point is of our malware detection, like I mentioned during our conversation. For example, at 1 a.m., when the same time something tried to happen in my environment, trying to infect my environment, but I have the block from the antivirus, for example. I have some solutions block this tentative, but why this happen always the same time? So I need to investigate more, because remember, the threats are changing all the time. So for example, for now I can block it, but if this attacker changing the techniques, maybe it will be blocked or not blocked. So remember about the questions. Why? Okay, network scan by internal hosts. Let's suppose that you don't have any offensive team. So why? Multiple alarms events from a single host. It's very interesting here because, for example, different infections, right, from the single host. Why it happened? Or even the systems is reinfected with the malware. So why we have in my environment this host or this system with a target, right? So has a target. Why I have this? So all those indicators is based on the threat hunting or EOA, indicator of attack. Remember, based on behavior. Okay, multiples logging from different regions. If you are just one user, maybe it's impossible to you stay in the same place in different places at the same time, right? And internal hosts using much SMTP protocol. If you have just an environment inside of your organization and you have internal hosts to try connect with a different SMTP, okay? Internal hosts with the many queries to internal and external DNS. When you have, of course, the environment with internal DNS, okay? So I try to explain more about this concept to you because it's very important you understand how I performed these tests that I would like to present to you during this conversation. It's just to, first of all, it's a part of a theoretical, idea. And now I would like to explain more about the tests, okay? So first of all, this is just a responsible disclosure for Cybereason company. And by the way, all those tests are reported to the company. I talk with the managers. I talk, by the way, with the CSO and Sam Curry. I would like to say thank you for Sam because he talk a lot with me. We have many meetings and I can help the solution to improve some information after this tests that I performed in my previous job, not in this company that I have been working now, but in my previous job, and I will explain more during this presentation. But I would like to say thank you to the Cybereason team and this participation and this returning actually from my reports, because I performed the same test in different vendors, but the answer is totally different. Because of this, I would like to say thank you for Cybereason. Okay, so let me explain more about the article presentation. I will be using my article here to explain all those steps here, right? So this is the infection with the ransomware using the delay policy. Actually, I would like to explain more about this first, because I have this in two different articles here, right? And I will present to you some information about this. Can you see? I think you can see my page here, right? And let me explain more about that. By the way, all those informations are here in my in my GitHub, right? So you can see my GitHub, Filipi86/thready hunting. You can find here all those tests that I have been executing, right? So you can see here the cyber reason, all those tests that I perform in here. You can see, you can read if you want. If you don't want, no worries about that. We continue to be a friend, okay? But here you can find many others articles that I've been working, right? So let me explain about the idea behind all this tests that have been executed in these different vendors, okay? So first of all, the idea is to perform, let me explain more about this first idea. So the idea of this test is a simulate of the some target attacks is using some evasive invasion techniques like a Dll injections using a payload created by msfvenom, very common in the Unix platform based on the Kali Linux or PowerOS, right? And another, it's using some PowerShell to try to explore some APIs or using some APIs in this test, right? The second test is using shell injection, right? To using the same payload using msfvenom, right? So just creating a reverse shell in this environment. And the third test, I will using another tool to execute the Dll Injection. The callers of this tool is remote the Dll injector, right? So from security exploited, just using different tools to executing the same test, right? So here is the scope of the test. Let me return here. This is the scope. This is the version of the test that I'm executing. And I use executing this in two different machines, and the Windows 7 and the Windows 10. So maybe you are asking why you execute Filipi in Windows 7? Because we have nowadays many companies with Windows 7. And by the way, this version, it is supported by the vendor, okay, by the cyber reason, right? So this is the host name, Thready Hunting Windows 7, and I have another with another Windows with Windows 7 operational system, okay? So I performed these two tests in two different machines. So this is the first, they need some requirement actually to perform. I need to update some requirements to execute in the Windows 7 specifically. So I update the version here just to be clear, right? During this test, I installed this updated. Sometimes the words is in Portuguese because when I performed this test is in Portuguese system operations, right? But I can translate to you. This is the update of the security from Windows. This is the KB of the Microsoft, basically this KB, okay? This is to be supported from the vendor, and all those things is updated, the machine is updated, okay? So this is the attacking validations. First of all, I enable all those, oops, sorry for that. I enable, let me return here. I enable all those features like anti-ransomware, anti-malware, PowerShell and .NET, exploit protections, collecting features, app control, and endpoint controls. I enable all those features and this cyber reason manager, okay? So that's my idea here. What happened, how I can execute the attack. So first of all, I enable the policies, as you can see here. And after that, my idea is to executing the attack. But I needed to disable the policy to see if my attack happened in the good way, right? It's my code, it happened. So first of all, I disable the policies to execute this attack, it was happen. And after that, I will apply the policies and execute the same attack to understand if the policy, it works well and it protects the environment, okay? So this is my point here. So first of all, I disable, as you can see here, I creating a new policy that I called here, policy used by Zup Security Labs, and I call no policy. I mean, I disable all those policies, and after that, I using the first test performed. I using this simple function from PowerShell to call this invoke Dll Injection PowerShell here to try using the Dll injection to infect some process ID here, and I will using the process from the cyber reason to infect the machine using the Dll injection. This is a very common or known techniques, right? So this is my idea here. So I execute here the PowerShell, right? So I call the binary from the internet, as you can see here, right? And after that, I invoke the solutions, as you can see here, choosing this process ID 5032, right? And I set here, by the way, the DLL that I am using my attack. And after that, I will inject the malicious PowerShell here. So as you can see here, it's easy. So I chose here this process 46. Let me 4604 Minion. It's not a fun name, but it's Minion host. It's a process from Cybereason, by the way. And as you can see here, I inject my PowerShell and I invoke the DLL injection. And I set here the process that I will inject my PowerShell inside of this DLL. And if you see here, I called the same kernel.32.dll name. I mean, I called the same name with the kernel32 DLL using this process ID, right? Because I will inject the DLL injection using these techniques in the Cybereason process, using the antivirus process to infect the machine, right? So just to using in this way, okay? So I execute this using this malicious DLL, and after that, let me show you here. Oops, sorry for that. Let's return here. Okay, I inject the attack here, and the next page is okay. And I open my machine here, and I open the netcat. Basically, not netcat. I'm using Metasploit actually to open the shell, because inside of my script I have this using as I mentioned, the msfvenom, and I open this port and I have the remote reverse shell here, as you can see here, the host name, and I call the name, it's financial, in Portuguese, financeiro, right? Just to suppose that I am a financial guy, okay? So the process injection, it's by this msfvenom created by me, okay? So now I have here the remote code execution that I can manipulate this environment. As you can see here, I have the control of the victim machine using the DLL injection to inject my process here, and to using the process, by the way, I'm using the process ID from the Cybereason, right? So just to be, this is the first test using here. This is the second, let me check here. Okay, the second step is, I mean, my attack here, it happened, okay? So I'm using the msfvenom to inject my shell inside of this DLL injection, and I will using msfvenom to create my binary, and after that, I have the reverse shell. But remember, I disabled the policy, so I need to apply the policy now here. So after that, I enable the policies, and I try to execute the same attack. As you can see here, I enable the policies used by Zoop Security Labs. I mean, I enable all those policies, as you can see here. But in this case, now I call the payload in a different way. I call the PA.dll. It's not more kernel32.dll. I using another DLL, right? PA.dll to gain the remote code execution in our victim machine. So as you can see here, this is my new attack, but now with policies applied in this victim machine, okay? So let's continue to see. Okay, let me go to the beginning here. The policy was enable, as you can see here, okay? It's applied, but as you can see here, I gain the access one more time. So maybe you are asking, what happened, Filipi? The solution didn't block it, didn't block you. And here is the good point. When I was analyzing these steps, I saw that we have a delay in this time to the policies applied by the manager. So let me explain more how this works in a security solution. When you have some solutions with antivirus, for example, and you have the manager in one side, in another side, you have an agent that you need to install in your endpoint. you have a heartbeat. This is the communication with the manager, with the binary side of the endpoint, okay? So we have a heartbeat. Sometimes, not sometimes, but you have the time with the communications between the client and the manager, right? So maybe the manager can be inside of your network, or maybe this manager can be in the cloud. Depends on the solutions that you install in your environment, okay? But you have the heartbeat, the time of the communications between the agent and the manager, right? So when you have some solutions, it's very important to understand what is exactly the time of this heartbeat. So not only to receive some new policies or new change or new, for example, update of for example, the engines, or new updates of the vaccine or whatever, but you have the heartbeat. This heartbeat can be in, for example, in 1 second or 1 minute, 2 minutes, 3 minutes, 5 minutes. It depends of the solution. And when I is performing that, I will analyze what is exactly this delay. And when I saw this delay, I thought, man, I can exploit this delay. So remember when I explained about the hacking, it's how you can look into some software and how you can use in your creative mind. So take a look at that. So why or how you can explore the simple delay of the updates, right? And this is one of these interesting things that I talk with the cyber reason, because when I talk with the cyber reason, the CSO talked to me and pass me the video, and not video, talk with me about the vision from the cyber reason. He explained me, Filipi, if the attacker perspective explore my manager, the attacker didn't disable all those. The attacker will disable all those policies in the environment, not only changing some policies and to try explore the delay in my environment. If the attacker perspective, the attacker will disable all those policies and will explore everything. This is the vision from the cyber reason. And I agree in part, but I agree. But I mentioned with the CSO in that case that if I am attacker, I will change in just some policies, because I would like to execute some attack more silence, right? So if you see how many times you execute some attacks in more silence way, the chance you have to be successful in this attack, it's higher, right? Because you will using in the silence attack. But if you like to disable everything, when you perform some attack, maybe the organization has some SOC team or some blue team. It's more easier to see this kind of attack happen. But if your attack is more silence, the chance to be successful it's bigger, right? So because of this, I explained to the CSO, I can just change in the policy, because I know if I found some delay longer, because take a look at that. Sometimes this delay, it happened because, or if the solutions has the long time, or maybe because the internet connections in some remote offices is not too big, right? So they don't have a good internet connections in these small offices. So sometimes if you have the connections not too good, you have this delay, and this is the opportunity from the attacker perspective to explore the victim machine, right? So when I see about that, I thought, man, if I have this delay, I can try to execute some ransomware in this environment. So here it's another article. When I explore the same vulnerability about the delay, let me explain here, and I will execute here in the same environment. So first of all, I using the same approach. I disable policies here, as you can see. And after that, I using this script to infect and victim machine. So this is a simple PowerShell, as you can see here. You have just information that the idea here is to call using this API from our Bazaar. I don't know if you know, but our Bazaar, it's a repository from the community that many researchers uploaded many different malwares there. And basically, I call this API and I request this specifically hash. This hash is from WannaCry, by the way. And here is the exactly folder that I will upload, right, in the victim machine. But the point is, Filipi, I don't know what is exactly the path in the customer. But remember, if you have the remote code execution, you can know about this path, right? You can agree with me. You have the control. You have the path that you have inside of the victim machine. You have about the credentials or what kind of privilege you have in this user that you explore, right? And after that, you call the API, but you need to have this API here from our Bazaar in your account, okay? And after that, you can automatically call the invoke web request to execute something, right? To download the zip file. And after that, you can extract this file. They will call some password. You can set here the password. And after that, you can call the invoke expression to execute the malware inside of the victim machine. And basically, this is the script in PowerShell, right? So we're using the invoke web request and you're using the invoke expression. So if you see here, is just a function from PowerShell, right? It's a true process in the Windows environment, right? So this is a simple script here developed by my colleague and me and Zup Innovation, right? So here is the script. So again, this script call and executing this behavior. So let me explain here. So if you see here in this results, I call here, right? I call this PowerShell called WannaCry because it's hashed from WannaCry once again. And I download here. This is the request by API from our Bazaar. Remember that you need to have this key from our Bazaar to download this specifically sample, okay? And after that, you need to have in your environment the zip file just to unzip this file. And after that, after you extract this file, you can execute itself in the victim machine. So after I execute this in victim machine, the victim machine, it was infected. Remember this test executing, I executed in the with the known policies, okay? No one policies enabled in the Windows 7 environment and the Windows 10 environment here. Let me show you here. Windows 7 here and here in the Windows 10 machine. So we have in both system operations here and the machine, it was infected, as you can see here. So now I need to apply the policies, okay? So the second point is I enable here the policies using, again, remember the policy, I enable about the anti-malwares, anti-ransomware, app control, and all those configurations here suggested, not suggested, but recommended by the vendor, right? Exploit protection, PowerShell.net, all those protections. So I enable, and after that, I executing the same attack. As you can see here, the policy, it is enable. I think it's small, but it's enable threat hunting policies, okay? So here is the time that I enable this policy. So the next step is to execute the same attack, right? And let's see here, I execute here the same attack, but if you see here, using the same hashing, as I mentioned here, and take a look what happened, it was infected just only Windows 7 machine. Why, Filipi, it was happened just only in Windows 7 machine? Just a simple case, because the time, let me see here, due to this delay, the synchronization between the server and the sensor that's installed on the victim machine during this 4 minutes, maybe more, the machine will be vulnerable to any type of attack. So as you can see here in the Windows 7 machine, the environment, it was infected because we have the delay to receive a new policy, right? And this is my point here in Windows 7. But when I execute this in the Windows 10, let's check here. We have this some, okay, let me check here. And the Windows 7, no, this is Windows 10. In the Windows 10, we have the time with the 7 minutes to receive a new policy. So in this way, the machine, it was infected. But if you see here, take a look at this. Here, in this case, I use another different hash. The hashing is different. It's not a WannaCry here. I'm using another hash there's another ransomware, Petya, as you can see here. So if you see here, this is the new log, okay? It's the execution, the program doesn't work. So I have some blockage in this case. I execute another PowerShell, as you can see here, Petya.ps1, it's a PowerShell, but I called another hash. As if you see here, I still running, not execute the malware. I download here the zip file, as you can see here. I open the file, I unzip the file, but when I try to execute the binary, I receive the blocked by the cyber reason. So why it happened? Because the update, right, of the Windows 10, when you compare to Windows 7, we have different time to update the new policies update. So that's my point here. It depends of the system operation that you have in your environment. It depends your office when you try to execute some updates, you know, and this is the point here. So let me explain here. Here it's a good point. When I execute the same process in the Windows 7, as you can see here, but in the Windows 7, it was infected. But in the Windows 10, it was blocked when you compare the both of the system operations. Okay, so let's see here. It's another test. It's another test, but it's for another talk. And yes, so here I finish my presentations, right? So here, some books recommended by this kind of talk about the more analysis. And by the way, I received this gift from the pack, and it's a pretty nice book. I really recommend you because you can improve your knowledge in malware analysis and malware hunting. So how you can see more deeply, and you can create your own tests in your environment, right? So remember that, just to clarify, my idea here is not to tell you what the best solution that you can use, if it's Cyber Reason, Trend Micro, or CounterStrike, or another one, is just to give you this creative mind. So how you can see the exact behavior of the binary, not binary, the antivirus, and how you can test you can execute the efficient and detection test. Why I'm telling you this? Because when you perform some POCs or proof of concept in your environment, you know, it's sometimes it's difficult to understand if the solution it's really good to protect about the threats, right? Because you need to receive some attack during the POC time. It don't make sense for me, right? And because of this, my suggesting you how you can create your own attack, and you can try to explore your own environment, right? So if you have any question, guys, so I'm here. And again, thank you so much, the staff team, for having me here, and my contacts again on social media. So if you have any question, please let me know. I can't hear you, Christian. I don't know if you are.
I always forget that I have a specific button on my microphone to mute as well. So I have like double mute to make sure that I'm muted. Anyway, so thank you very much for your presentation. That was quite interesting. I don't see any questions in the Q&A, but I do have one question about like, so this was specific to Cyber Reason. I was wondering if you did any type of testing on any other vendor products to see if they were kind of vulnerable, they had the same vulnerability?
Actually, when I perform these tests, I perform these tests in a Cyber Reason, CrowdStrike, and so forth. And actually, this is not a mainly test. The mainly test it is to understand how the engine works with no malware. So this is the first test. The second test is to perform some actually to manipulate some malware inside the environment. This is the second test, the mainly test, right? So the first is download many no malwares from the Dll repository from the GitHub, for example, or many malwares from our Bazaar. So this is the first. The second is I will copy, for example, 20 malwares in some folder, and I will copy and paste in another folder, because when you perform this, you are writing some new files inside the hard disk. So if you have some engines, they need to perform some scanning this new file. And this is the second. In the third test, I will be executing the full scan in the machine to understand about this behavior. all those tests that I am performing, it's always using real malwares, right? So this is the main test that I perform. But in some vendors, I saw different behaviors about the engines. So the simple answer about the question is about the delay time. I just performing the cyber reason because we had in that time this solution. So my focus is more in the cyber reason. But I have a different surprise in a Sophos and maybe mainly in Counter-Strike. And by the way, I have a talk about that. So how you can explore using a PowerShell, using a Python script, and how you using all those informations are in my GitHub. You can see many information about the tests. In some tests, I have the demo, by the way, the video that I recorded. And but yes, my suggestion from the audience is executing tests in your security sensor, because only this way you can exactly prove if this solution is efficient or not. Because when you don't execute this test, the solution maybe can be protect you, but you just to know if it works well if you're suffering some attack, right? So that's my point here.
Yeah, that's quite interesting, and it also kind of reminds me, and it kind of the word that comes to my mind is methodology, right? It seems like you have like a methodology to try different kind of EDR products, and I wonder, like, do you have that published somewhere? Like the pentesting methodology is like, okay, you do reconnaissance, you do this, you do that, right? It would be interesting to know or to read about like the methodology that you use, like the basic things that you look for when you are evaluating one of these EDR products. Like first, download the second, like try to disable it, re-enable it, and put real malware and different types of malware. Anything like that? Do you have anything published around that?
Yeah, I have all those information that I publish. It is my web page and the LinkedIn, and about my evaluations and about my tests, all publishes are there. And another interesting test that I'm executing is, for example, we have in the Malware Bazaar, for example, you can call by API all those malwares uploaded during the day. All those malwares uploaded during, for example, the day. The Malware Bazaar has a repository. When they put all those malwares there. So, for example, probably let's suppose that you have on Wednesday, Malware Bazaar can receive, for example, 1,000 malwares on this day, right? So it's a daily batch called daily batch. So you can request this daily batch, and you can download more than 1,000 malwares in your environment. So you can simulate, for example, some outbreak infection in your environment, as I executed with Sophos, for example. And the answer is totally, I will use this word. The answer. It was bullshit, right? Because the security solution tell me, oh yes, we try to execute these tests, and I mentioned the engine in my environment. The CPU is too high, the memory is too high because I'm outbreak infection, and the Sophos telling me, yes, it's true. We know that. So that's the high CPU, high memory. So, if the engine is broke, so what happened with the protection? I didn't receive the answer about that, right? So that's my point here. And the answer again from the Sophos, it's not exactly test that Sophos executing in our engine. So nice, but if I suffering some outbreak infection, so how does your solution happen? You didn't test that. I know probably it's not common attack, but now I know how I can broke the Sophos, right? So the mindset, and but unfortunately, in some security sensors we don't have this open to take our open talks, right? So open conversations to talk more about the some efficient detection tests. And I think that it's very important to open to conversation with the researchers, with to understand, because man, some organizations like a Gartner, like Forrester, Kuppinger, Cole, it's a good reference of the organizations with some information about the security solutions recommendations, but how exactly happen the tests, right? It's a commercial test or it's a detection test with a real malware. It's a real life, right? This is the point here in the end of the day, right?
Yeah, I feel like sometimes you get tests with malware that they of course know that they're going to detect, right? But when you try something else, you never know. All right, so we've got another question in the Q&A. I'm going to read that for you. Is how did you manage to do isolation on the virtual machine for malware analysis and still get updates from AV? I'm planning to get into malware analysis and threat hunting in the future, and I'm wondering how to do that. That was asked by Terence.
Yeah. Good question. So how did you manage to do isolation of the VM for malware analysis? This is a good point here because, for example, when you have some virtual machine, you can test the malware. But when you created this virtual machine, you configure some networks and you execute the malware inside of the virtual machine. But it's totally different. And by the way, it's a misconfiguration concept when you tell, not in this case the question, but when some people tell about you have the virtual machine and I have the sandbox there. No, it's not a sandbox, it's a virtual machine. Sandbox is that you have a virtual machine with many engines inside of that. And these engines is responsible to understand the behavior of the malware, right? So this is the point here. And when you can install, of course, the antivirus inside of the virtual machine, but you need to have some scripting running inside of the virtual machine to understand all those behavior when you perform this malware inside of this, when you run the malware inside of the virtual machine. And of course, because nowadays we have many malwares using the sleep techniques, as I mentioned during the conversation. It's the simple functions important from DLL, from the Microsoft, by the way, and you can import of this virtual machine. And sometimes, because the malware will see the environment and the malware will think, I am here in the virtual machine, I can execute my malicious stuff, right? So this is the point here. And of course, when you need to perform some analysis, it's very important you perform this in our isolated environment, like a virtual machine, as you mentioned. But it's just to clarify the concept when you talk about the sandbox and virtual machine, right? So, and this is the first question, right? And another question is, I'm planning to get into more analysis and threat hunting in the future, and I was wondering how to do that, right? So that's the point. We need to understand these different behaviors, right? And how you can investigate that in the sandbox concept and the virtual machine concept. And by the way, and in my GitHub, I have some awesome malware analysis and in awesome threat hunt, if I remember correctly, I forked this awesome project just to be easier to find some information. And you have there in the awesome malware analysis, many different antivirus scanning and sandbox using the cloud, and you can perform some malwares inside that, and you can see the behavior. All those techniques is based on the analysis, dynamic analysis, right? Because when you perform this malware in some controlled environment and to see the behavior in runtime. When you talk about the statistical analysis, you analyze the malware in not a runtime. It usually is more safe, right? Because you see the structure of the code, how it's specifically DLL called in the system operations, but you don't execute sometimes in the environment, right?
So thank you for answering that. I would also like to give a bit of answer to Terence there about like the isolation that you usually have on your virtual machine. You configure your network and you put a firewall on front of your virtual machine. So you configure very tight rules that you only allow the virtual machine to talk to basically the service that you wanted to talk. So you allow to talk with the IP addresses of where you AV get the updates, for instance, but you don't allow it to talk to anywhere, to anything else. And that's the only traffic that you allow, for instance. So that's more or less.
Yeah, and another point is when you talk about the virtual machine is sometimes the analysts like to disable the network with the virtual machine, right? To just to see the behavior or not to spread the network or the inside of this environment. But sometimes the malware in your environment needs to access the internet. So because of this, it's, for example, if it's a dropper, for example, dropper, it's not a totally malicious because the mainly strategy, not many functional strategy, the main function of the dropper is download another malware. So they need to access the internet to drop another malware, to download the malware actually. So, and this is the point here.
All right, thank you very much for all the answers there and for the talk. It was a pleasure to have you here.
Yeah, thank you everyone. Thank you again, Christian, for having me here. And I hope next year to be in person. And by the way, in January I will move to Portugal. I will be next to Barcelona. And si quieres hablar en español, no hay problema. Podemos hacer el cambio. Y muchas gracias. And that's it. Thank you so much, everyone.
Perfect. Thank you very much.